this lesson, we're going to be talking about nth roots, radicals, and rational exponents. An nth root of a number c is x, such that x to the n is equal to c. An nth root can be represented using a radical symbol by x equals the nth root of c. So let's say that I had 2 to the third is equal to 8. I can solve and get this 2 by itself by taking the cube root to get rid of this exponent of 3. And I would do that on both sides. And now I know that 2 is equal to the cubed root of 8, which is true. The cubed root of 8 is 2 because 2 times 2 times 2 is 8. And vice versa, I can cube both sides. And the cube cancels out the cube root. And now I have 2 to the third is equal to 8, which is a true statement. So it goes back and forth. Now, when you take odd roots, you get one answer. You can take the odd root of a positive and you can take the odd root of a negative. You get one answer. It's either a positive answer or a negative answer. When you take an even root, you will get two answers, a positive and a negative. So I'm going to give you two examples of this. So what are the real cube roots of 125? That's like saying what number to the third power is equal to 125. Now, I can solve this by cube rooting both sides and saying to myself, what times itself 3 times equals 125? And the answer to that is 5. Now, this is an odd root. I'm only getting one answer. If I wanted to see this graphically, I could take my x cubed and subtract the 125 and set it equal to 0 so that I could see what the roots of my equation were. All right. So let's graph the x cubed minus 125. And you're going to see right there, it crosses the x-axis at 5. Now, x cubed minus 125 has 3 answers because it's a cube. The degree is a 3. So one of these is real. The other two are imaginary. So I have the one real root. And it is 5. All right, so what are the real fourth roots of 16? So what number to the fourth power would equal 16? So I could fourth root both sides, but because this is an even root, I'm going to have a positive answer and a negative answer, and that is 2 or negative 2. Now I can do the same thing on this and see it visually. So I have x to the fourth minus 16 equals 0. So I'm going to graph x to the fourth minus 16, and I see that it crosses at 2 and negative 2. Now, if you are unsure what number multiplies that many times to make that number, you can always find that in your calculator. So, for instance, on number 1, it was the cube root of 125. Now, if I go to math, there is a cube root option right there. All right, number 4. So I could just do cubed root of 125. And it's going to tell me that that is 5. Okay, now there is not a fourth root, but if you press 4 and then go to math and choose option 5, it'll put the 4 there. If you don't put the number first before you go to math, then you just have to fill in that little box. All right, so I do the fourth root of 16, but it's only going to give me the positive answer. So I have to remember that when I do those even roots, I'm going to get a positive answer and a negative answer. All right, so I don't really have to set this up as what number to the fourth power equals 81. I can just say, what is the fourth root of 81? Since this is an even root, I know it's going to come out to be a positive and a negative, so I end up with positive and negative 3. And what are the real cube roots of 64? So the cubed root of 64. That is an odd root, so I'm going to have just one answer, and it is a positive 4. Explain what each fractional exponent means, then evaluate. All right, so I know that this number on the bottom represents my root. This is my root number. So I know that this is a fourth root, okay? This number on top represents the exponent of my base. So this could be rewritten as the fourth root of 16 to the first power. Now I can put that 1 here, or I can put it out here. That's fine too. But we're going to look at this a different way, all right? I can rewrite this as something to the fourth power raised to the 1/4 power. And the reason that I want to do that is because when you have, let's say we have 2 to the third to the 1/3, I multiply these exponents. When I have an exponent raised to an exponent, I multiply them. So 3 times 1/3 is just 1, and the answer to this is 2. So I know that the fourth power is going to cancel out with the 1/4 because they're inverses. But what number to the fourth power gives me 16? That would be 2. So 2 to the fourth to the 1/4. 4 times 1/4 is 1, so this is just 2. Now I realize that this is an even root. So if I was solving an equation, I would have a positive root and a negative root. So we're just going to say that the answer to this is 2. All right. All right, so 27. If I look at this, I know this is a cube root. So I can say 27. Is that a perfect cube? Yes, it is. So I know that I can take the cubed root of 27, because that's the same thing as 27 to the 1/3. That means that this is a cube root. And then I take it to the power of 2. Now, 2 and 1/3 are not canceling, but I do know that 27 is a perfect cube. The cube root of 27 is 3. And then I can take that to the second power. 3 squared is 9. All right, number 7. This is a square root, and I know that 25 is a perfect square, so I'm going to take the square root of 25. Now, when we have a square root, we don't write the little 2 outside in the little nook, okay? It's just understood to be there. So this is the square root of 25 to the first power, so we don't write to the first power. The square root of 25 is 5. All right, and then I'm looking at this one again. I know that this is a fifth root. 32 is a perfect fifth root. So the fifth root of 32, and then I'm going to raise that to the second power. The fifth root of 32 is 2. Raised to the second power is 4. All right, in general, if the nth root of c is a real number, then I can write the nth root of c as c to the 1/n. So if I see a fractional exponent, I can view those as being some sort of radical, all right? And so furthermore, if m is an integer, then let's say that I have 2 to the 4/3. That's the same thing as 2 to the 1/3 raised to the 4th. I can split that up because remember, if it's 4/3, that's the same thing as 4 times 1/3. And furthermore, that's equal to the cubed root of 2 all raised to the 4th power. Now, notice this is really similar to this. The only difference is the m is moved inside. You can write it either way. The m can be on the outside of the root, or it can be underneath on the inside of the root. So I know that the cubed root of 2 to the 4th would be the same thing as taking 2 to the 4th to the 1/3, which is the same thing as 2 to the 4/3. So again, we're going to evaluate these expressions just like we were in the last little section. I know that 32 is a perfect fifth root, so I'm going to take the fifth root of 32. And because it's a perfect fifth root, then I know I can take it and cube it. So the fifth root of 32 is 2, and then I'm going to cube that. 2 cubed is 8. All right, I realize I have a negative in this exponent, but that's okay. We're going to take care of that later. The cube root of 27. And I'm going to raise that to the negative second. So the cube root of 27 is 3. It's a perfect cube root. And then I'm taking that to the negative second. And if you recall, to get rid of a negative exponent, you're just going to take your base of 3 Think of it as being over 1, and you're going to flip it, which then changes your power to a positive. So now I have 1/3 to the second power, and then we square top and bottom. 1 squared is 1, 3 squared is 9, so my answer is 1/9. All right, on number 11, 50 is not a perfect fourth root. So on this one, I know I'm not going to get a nice, integer. So I'm just going to change this to the fourth root of 50 raised to the third power. Remember, you could also put that 3 inside and do 50 to the third. Either way it comes out. I'm just going to plug that in my calculator as is, and that gives me 18.8. All right, we're going to simplify each expression and assume that all of our variables are positive. So if you will recall from doing square roots, I know that x to the 8th is a perfect square because this exponent divides evenly by my root number of 2. Because I can write that as x to the power divided by root, and that gives me x to the 4th. So I just have to take the power and divide it by the root number to take the root of it. All right, so when you have variables and numbers, I like to kind of split them up so that I can view them separately. So 32 is a perfect fifth root, that's 2. And m to the 15th is also a perfect fifth root because 15 divides by 5 evenly. So if I take 15 divided by 5, that gives me 3, so the answer is 2m to the third. All right, both x to the 20th and y to the 8th are perfect fourth roots because both of the exponents divide by 4. So x to the 20 divided by 4 is 5, and y to the 8th, take the fourth root of that, and that would be y to the second because 8 divided by 4 is 2. All right, number 14. Now, I stated earlier that you can take odd roots of negatives, but you cannot take the even roots of negatives because that's going to give you imaginary answers. So I can take the cube root of -8. I'm also taking the cubed root of a to the third, and I'm also taking the cubed root of b to the 9th. So the cubed root of -8 is -2. The cubed root of a to the third is a, and the cubed root of b to the 9th is b to the third. Remember, just take those exponents and divide them by the root number. So number 15, we have the fourth root of 256. We have the fourth root of x to the 12th. And the fourth root of y to the 24th. These are all perfect fourth roots. The fourth root of 256 is 4. The fourth root of x to the 12th is x to the third. And the fourth root of y to the 24th is y to the 6th. All right, we're going to solve the equation. All right, so a common misconception is that when I'm solving and I have like 2x to the 5th equals 64 is to go ahead and take the 5th root. However, 2 is not being raised to the 5th root. If it were, it would be written like this. So before I can take the 5th root, I first have to get rid of the 2. So I'm going to divide by 2. X to the 5th is equal to 32. Now I can take the 5th root, and since it's an odd root, I will only have one answer. So x is equal to the 5th root of 32, which is 2. Same thing on 17. I'm going to start by dividing by 3. So I have x to the 4th is equal to 625. Then I'm going to take the 4th root. Because this is an even root, I have a positive answer and a negative answer. And x is equal to plus or minus the 4th root of 625, which is 5. All right, same thing on 18. I'm going to divide by 5. So x to the third is equal to 64. Take the cubed root. It's an odd root, so that tells me I'm going to have one answer. The cubed root of 64 is 4. And then the last one, we're going to start by dividing by 2. 162 divided by 2 is 81. I have a 4th power, so take the 4th root. That's an even root, so positive and negative answer. So p is equal to plus or minus the 4th root of 81, which is 3. garden water fountain is made of 2 cubes. The larger container has edge length 2 centimeters longer than the edge length of a second cube. When the larger cube empties into the smaller cube, how much water will spill over the edge of the smaller cube into the base? The volume of the larger cube is 729 cubic centimeters. So if we want to know how much is spilling out, okay, we have a larger cube, so we are doing volume, and we have a smaller cube. So if I pour the larger cube into the smaller cube, obviously what can't fit into the smaller cube is going to, flow over the edge. So if we had the volume of the larger cube, we could subtract the volume of the smaller cube, and that would give us the leftover part that won't fit into the smaller cube. So first, let's think about the edges. So I'm just going to say that X is the edge of the smaller cube. So edge of the smaller cube. And it told me that the larger one is 2 centimeters longer than the edge of the second cube. So if the edge of the second cube is X, I would add 2, and that gives me the edge of the larger. Okay, now we are doing volume. So I need to know the volume of the larger cube, and then I need to know the volume of the smaller cube. So let's start with the larger cube. All right, and we're going to do that because they told us the volume of the larger cube is 729. To find volume, you do length times width times height. Since this is a cube, the length, width, and height are all sides of a square that's a cube. All right, so a three-dimensional square. And so we will take the edge length times itself 3 times. So that would be x plus 2 times x plus 2 times x plus 2, which is x plus 2 cubed, and we know that that's equal to 729. Now I need to solve for x, so I'm going to cube root, because all of this is being cubed, cube root both sides. Now I only have one answer because it's an odd root. The cube root of 729 is 9. So I know that the side of the larger cube is 9 because x plus 2 is the side of the larger cube. So x plus 2 is 9. Now, if I solve for x, I know that the side of the smaller cube, which is represented by x, is 7. So 9 cubed would be the volume of the larger, minus 7 cubed would be the volume of the smaller. Now, they gave you the larger. 9 cubed is 729. They told you that already. All right, 7 cubed is 343, and if I subtract those, I get 386, and that's the volume of water that's going to spill over. So this would be in centimeters cubed.